Title of the first section is Review, Graphing, Rational Equations. In this section, we'll review graphing rational equations, which has vertical, horizontal, asymptotes, and holes. First equation we'll graph, f of x equals x plus 2, all divided by x squared minus x minus 6. When first graphing, we want to find the vertical asymptotes, which again are where the denominator is equal to 0. So we can first factor and find the values where x is equal to 0. Factoring x squared minus x minus 6, you could factor this using the diamond method. Two numbers that multiply to get negative 6 and add to get negative 1. Those numbers would be negative 3 and positive 2. So this would factor to x minus 3 and x plus 2. Setting this equal to 0, x minus 3 equals 0, we'll have x equals 3, and x plus 2 equals 0, x would equal negative 2. So the vertical asymptotes for this graph would be x equals 3 and x equals negative 2. For the horizontal asymptotes, we can look at the degree or highest exponent in the original equation. The numerator, we have x to the first, or a degree of 1. The denominator, we have x squared, or a degree of 2. So the numerator has a lower degree than the denominator. Anytime the numerator is a lower degree, the horizontal asymptote will be y equals 0. And last part before a graph are to find the holes. Holes again are where the factor cancels. In the numerator, we have a factor of x plus 2. And the denominator, we have a factor of x plus 2 also. So if we cancel these out, x plus 2 divided by x plus 2, we'd set this factor equal to 0. So our hole would be at x equals negative 2. The answer to x plus 2 equals 0. Again, when you have a hole and a vertical asymptote with the same number, we can cross off the same number for the vertical asymptote. Since we're graphing, we only have to graph one, which would be a hole at x equals negative 2. From here we can draw the graph. The vertical asymptote at x equals 3. Again, a vertical asymptote is a dashed line, in this case going straight up and down, in which the graph cannot pass or go through the vertical line. The horizontal asymptote at y equals 0. Y equals 0 is also on the x-axis. So we'll have another dashed line across the x-axis, which means again the graph cannot cross the horizontal asymptote or cross over the x-axis. After we start the graph, we'll put a hole at x equals negative 2. When we have the vertical and horizontal asymptotes, now we have 4 sections to the graph. Again, the graph is on the left side of the vertical asymptote. It will either curve on the top or curve on the bottom. And same thing on the right hand side, the graph will either curve along the top section or curve in the bottom section. To figure out if it's the top or the bottom for the graph, we can do a t-table. Picking numbers, we can pick one number to the left of the vertical asymptote and one number to the right. We can pick any number to the left. For example, we could pick 2, 1, 0, or any negative numbers. Easiest number to pick would be 0, since 0 is easy to add, subtract, and multiply by. If x equals 0, plugging a 0 into our original equation. The original equation, again, at the beginning of the question, x plus 2 would be 0 plus 2, which would be 2. And the denominator, x squared minus x minus 6, all the x's would cancel or be 0, and we'll be dividing by negative 6. Reducing this, we'll have negative 1/3. Since we have a negative number, that means the y value is below the horizontal asymptote. So at 0, negative 1/3, you could graph that point. And since the point's below, that means the graph will curve going parallel or close to the horizontal asymptote, curving, and going parallel or close to the vertical asymptote also. There is a hole at x equals -2. So if we go over to -2, we can draw an open circle. This open circle represents this point as undefined. The graph skips this point, but does not include the point. For the second half of the graph on the right side, the x vertical asymptote is at x equals 3. So we want to pick a number to the right of 3. In this case, again, we could pick 4 or any number 4 or bigger. If we use 4, plugging the 4 in again to the original equation, the numerator is x plus 2 or 4 plus 2, which would be 6. And the denominator was x squared. 4 squared would be 16. Minus x would be -4 and -6. Simplifying this out, 16 minus 4 would be 12. Minus 6 would be 6. And we'll have 6 divided by 6, which would be 1. Again, y equals 1 or a positive value, which means the graph in this section is the top right corner. And again, the graph will curve next to the vertical asymptote and go next to the horizontal asymptote also. And that would be the graph for the question. Second question and last question for the section. G of x equals x squared plus 6x plus 5, all divided by x plus 1. Again, graphing this rational expression where we have variables or x's for the numerator and denominator, we can find the vertical asymptotes. Vertical again is where the denominator will be equal to 0 or undefined. X plus 1 equals 0. That means the vertical solving x plus 1 equals 0 will have x equals -1. For the horizontal asymptotes, horizontal again, look at the degree or highest exponent for numerator and denominator. This time the numerator has a higher degree or higher exponent than the denominator. Anytime the numerator is higher, horizontal will be none. So there is no horizontal asymptotes. And last part before a graph is to find the holes. Holes again are factors which cancel out in the numerator and denominator. The numerator we can first factor, x squared plus 6x plus 5. We can factor that to 2 sets of parentheses. 2 numbers that multiply to be 5 and add to get 6 would be x plus 5 and x plus 1. Looking at the common factors, we have x plus 1 in the numerator and x plus 1 in the denominator. So these 2 factors would cancel or give us a whole. Again, setting this equal to 0, x plus 1 equals 0, the whole would be at x equals -1. And when you have the vertical asymptote and the whole as the same number, we can cross off or ignore the vertical asymptote and the whole would take the place on the graph. From here we can draw the xy axis. This time there are no vertical asymptotes to graph. Anytime there's no vertical asymptotes to graph, the graph will not curve up or down in any section, but will rather be a continuous graph, except for the spot that we have a hole. And there's none horizontal asymptotes, so there'll be no curving up or down. We'll basically have a single graph with a single hole. Looking back at the equation, if we cancel out the x plus 1 for the numerator and denominator, the only factor or only question we have left is x plus 5. If we set this equal to y, the original equation will be the graph of y equals x plus 5. Only difference is we'll have a hole at x equals -1. Graphing this function, which is a linear function, we can graph using mx plus b, slope-intercept form. The slope m, number in front of x, would be 1 or 1 over 1, and b, the y-intercept, last number, which would be 5. So graphing, we can start at the y-intercept, which is 5. Having a slope of 1 or 1 over 1, we'll go up 1 spot and to the right 1 spot. We would connect this to make a straight line. The only difference is we have a hole at -1. So if we go over to -1 to where the graph would be, we'll have an open circle, meaning this point will not exist for the graph, but every other point along the graph will exist. So the function that we graphed is the exact same graph as x plus 5 with a hole at x equals -1. Title of the last section today is Graphs with more than one vertical asymptote. In this section, we'll look at a graph that has more than one vertical asymptote, which will change the number of sections that we'll graph for the equation. First equation and only equation for the section, f of x equals 3 divided by x squared plus 4x minus 5. Again, graphing rational functions where we have variables or x's in the denominator. We can first find the vertical asymptotes. Find the vertical asymptotes where the denominator is equal to 0, which in this case we can factor first and then set equal to 0. Factor in x squared plus 4x minus 5. Two numbers again that multiply to get -5 and add to get positive 4. That would be x plus 5 and x minus 1. And again, setting these factors equal to 0, x plus 5 equals 0, and x minus 1 equals 0. We'll get the two vertical asymptotes, x equals -5, and also x equals positive 1. For the horizontal asymptotes, again, we'll look at the degree or exponents for the numerator and denominator. Having a single 3 has no variable or x's, so the degree of the numerator will be 0, and the degree or highest exponent would be 2 for the denominator. So the numerator is lower than the denominator, which means the horizontal is y equals 0. And looking for any holes in this graph, we have just a single 3 in the numerator, so there's no factor to cancel, so holes would be none. Graphing from here, we can draw the xy axis. Two vertical asymptotes, so we'll draw two vertical lines, one at -5 and the other at positive 1. The horizontal asymptote, y equals 0, will be the dashed line going across the x-axis. In this question with two vertical asymptotes, instead of 4 sections to graph, now we have 6 sections to graph. Each section again will either have a curve on top or a curve on bottom of the graph. The middle sections will be parabola shapes, either going up or down, and the right side will either have a curve on top or a curve on bottom. Graphing the left-hand side, again we can do a t-table to figure out if the graph is on top or bottom of each section. The first vertical asymptote's at -5, so we can pick a number to the left of -5, such as -6. 3 will be on the numerator from the original equation, and plugging in a -6 for the x values, x squared, or -6 squared would be 36, plus 4 times a -6 would be -24, and -5. Solving this out, we'll have 3 divided by 36 minus 24 would be 12, minus 5 would be 7. So our first point would be -6, and the y value is 3/7, or is a positive number, which means the graph will be on the top half of the left-hand section. And again, the graph will curve and go next to or parallel the asymptotes. For the second section, the middle section, we could pick any number between -5 and +1. Nice easy number again would be 0. Plugging a 0 into the original equation, 3 will be the same on the numerator. The x's will be 0, and we'll be left with a -5. So 0 and 3 over -5, or -3/5. Again, a negative number will be below the x-axis and below the horizontal axis. Since we have vertical asymptotes on both sides, the graph will curve or go parallel to each of the asymptotes and then curve back down since we have a negative number. And the last section of the graph, the right-hand side, the vertical asymptotes at 1, so a number to the right of 1 that we can select would be 2. Plugging a 2 into the original equation, we'll have 3. 2 squared will be 4. 4 times 2 would be 8, and -5. 3 over 4 plus 8 would be 12, -5 would be 7. So we'll have a y value of 3/7, or a positive y value, which again means the graph is above the horizontal asymptote. And that would be the graph for the section.